This student book belongs to a set of student books which altogether provide a complete set of information to master SDMX. This student book looks at the relation between metadata reports and metadata structure descriptor concepts, the metadata structure definition, and the design steps and the details of a metadata structure definition. In the SDMX model, objects can have explanatory texts explaining the main features of data. This is typically described as reference metadata. Reference metadata can be stored and exchanged without being embedded in the data message. In other words, those metadata are normally linked to the object by a simple reference to the object. Another important point is that very often these metadata are associated not with specific observations or series of data, but with entire collections of data, or even with the institutions providing the data. From a content point of view, reference metadata can provide information on the statistical concepts used, on the methods used for the production of the data, or on data quality. Reference metadata may be organized in metadata reports, which provide a structured presentation of specific metadata items, such as contact, metadata update, or classification system. A reference metadata report has a metadata structure definition, which describes how it is organized. This is similar to a data structure definition describing how a data set is organized. A metadata structure definition identifies what metadata concepts are being reported, how these concepts relate to each other, what their presentational structure is, as free text or as coded values, and to which data object they are attached. Often, reference metadata relate not to a single set of data, but to an entire data collection and dissemination process. Such metadata are not appropriate to be reported or exchanged with each data update, as these do not vary so often, or sometimes do not relate directly to the single data set which is being transmitted. Reference metadata are sometimes referred to as quality reports based on a standard such as the IMF DQAF or Eurostat's Euro SDMX quality report structure. On the other hand, consider the unit of measure. Without this information, one cannot effectively process the observations contained in a dataset, since very little can actually be understood about the values. Information such as this should be contained in data attributes and should accompany the data directly. Reference metadata allows to capture details such as individual components of the contact details, which would be only a single text string in the dataset. This is an example taken from the Eurostat website in the population statistics tables. The figure is an extract of the Eurostat publication tree in which the datasets are organized in categories. Next to some nodes in the tree, an icon with M indicates the existence of metadata associated to a dataset or a collection of datasets for particular categories. Clicking in the tree on an icon next to a category level opens a new window displaying the reference metadata pertaining to the category. In this example, the information applies to all the datasets for the population category. This figure shows that reference metadata contains descriptive information such as contact details, last updates of the reference metadata, and information on statistical presentation. The reference metadata window can present the information in a clean and organized manner because the metadata structure definition defines the structure of the report and provides useful names and descriptions for the information being reported. In short, this example demonstrates the utility of metadata structure definitions in support of such quality frameworks. The SDMX information model intentionally models the metadata structure definition in a way that is similar to the data structure definition. Where the dimension list, and to some extent groups, in the DSD contains dimensions which define how a dataset described what is being measured, the full and partial target identifiers in the MSD contain identifier components which define how a metadata set identifies what object is being described by the reference metadata. In the DSD, the attribute list and measure list contain attributes, measures, and attachment information which describes what information is in the dataset and how it is presented. Similarly, the report structures in the MSD contain metadata attributes which describe what concepts are included in the reference metadata set. The metadata structure definition defines the target objects to which metadata attributes defined in a report structure can be attached. There are two types of target identifiers, full and partial. Both target identifiers consist of individual identifier components. An identifier component must have an association to an object type, which must be one of the formally recognized object classes from the information model, for example, a category. An identifier component can have an association to an item scheme which enumerates the possible values for the component. An item scheme is a generic name in the information model whose specific types are code list, concept scheme, organization scheme, and category scheme. A target identifier in a metadata structure definition consists of one or more identifier components. These individual identifier components are combined in the target identifier to describe the object which the reference metadata describes. This is a similar principle as on the data side, where the individual dimensions serve to identify the observation value, except that for metadata, the artifact that is identified can be any artifact in the SDMX information model, and not restricted, as on the data side, to the observation value. The full target identifier specifies all of the identifier components in the scope of this MSD, whilst the partial target identifier identifies a subset of the identifier components to which metadata attributes may be attached. Each partial target identifier must contain only those identifier components required to identify a single SDMX artifact. For example, if it is required to attach metadata to either a code or a code list, then there must be two target identifiers specified. One that contains the identifier components for a code list, the maintenance agency identifier, and the code list identifier, and one that contains the identifier components for a code, the maintenance agency identifier, the code list identifier, and the code identifier. This scheme provides an example on how a metadata file based on the Euro SDMX metadata structure is structured. In this example, the full target identifier is named provider and flow target and will use two identifier components to identify the target object. data flow ID, which will be associated to SDMX class data flow, and data provider ID, which will be associated to the SDMX class data provider. For the data provider identifier component, an organization scheme is used for the representation. For the data flow ID identifier component, a category scheme is used for representation. This file shows an example of the SDMX ML target identifiers that have been described previously. The metadata structure definition is declared with an ID here, ESMS. Then both the target identifiers are defined and the identifier components with their linked representations. The next step in defining a metadata structure definition is defining the structure of the metadata reports. This structure is described in one or more report structures. The content of a report structure are metadata attributes. A metadata attribute can comprise so-called child metadata attributes. In this way, it is possible to define hierarchical structures of metadata attributes. In addition, each report structure is associated with a target identifier. A metadata attribute takes its semantic from a concept which is defined in a concept scheme. As with a dimension or a data attribute in a DSD, the metadata attribute can take a coded representation from a code list or define an uncoded text format. The report structure is defined in the metadata structure definition. It details the metadata attributes used to represent the reference metadata. Metadata attributes are organized according to child-parent relationships to define a hierarchy. Each of them takes its semantic in a concept scheme in which a representation can be defined, such as format and code list. Here is a sample of the full report structure that was defined in the previous scheme. One can see that the report structure is linked to the full target identifier provider and flow target, which identifies the target objects to which metadata attributes are attached, for example, the contact metadata attribute. Also highlighted, the contact organization, which is defined as a child of the contact attribute. The resulting hierarchy drives the presentation of the metadata report. To summarize, reference metadata sets are structured according to metadata structure definitions, using a set of main concepts. These main concepts are divided into sub-concepts representing metadata attributes for which values can be reported. In the example, the concept contact organization holds as metadata attribute the value Statistical Office of the European Communities, Eurostat. Reference metadata reports, structured through these specific concepts, may contain conceptual metadata describing the data structure concepts, methodological metadata describing methods used for the data production, and quality metadata describing the different quality dimensions of the statistical data. With the SDMX 2.1 release of the standards, some changes were introduced. Using more meaningful terms, the full target identifier and partial target identifier are replaced by the single metadata target. The related identifier component is renamed target reference, containing the identification elements of a target object. Another important change is that, in version 2.1, the target object to which metadata can be attached is not limited to simple objects, such as a code or a category, but may be better identified at any level. Furthermore, it is even possible to specify a URN as the identification mechanism, and the metadata report can also be specified as XHTML. Some changes have also been made for the reference metadata messages. The structure-specific metadata set, previously called metadata report, is renamed to structure-specific metadata to be more consistent with the data messages. The XML structures of the generic and structured metadata sets have also been aligned. In version 2.0, the generic metadata message was structured much differently from the structure-specific metadata message. In version 2.1, the two formats are quite similar, with the same tags being used for each level of the metadata set structure, and there is a better equivalence between data messages and metadata messages. SDMX is sponsored by 7 international organizations since 2001. If you want to know more about it, look at sdmx.org, which provides the technical standard and guidelines. And also links to other resources, such as the SDMX info space and self-learning tutorials on specific topics.